So we're going to be presenting on Oncor's AUD journey today, and we're going to be focusing on what Oncor calls the live distribution model. And essentially what that is Oncor's design and GIS tools focus on accounting for materials, geographical location, and electric connectivity. Once our design is in the GIS, we actually migrate the design data and the GIS connectivity into our OMS system. And the kicker there is we actually do that multiple times. So we'll do that from our first design all the way through our last as-built so that we continue to have live updates on the OMS system for the designs that are in process. So if I've already lost you, it's going to be a long presentation. But we thought this is one of the more unique things about our project, and we think that some other utilities might approach their architecture this way in the future. So we wanted to give you guys an insight into the challenges we face and how we've tackled them. So before we get started, two things I want to cover. First of all, we've taken some liberties with this presentation. So configuration team, if I skip over a few things, please don't call me out. We're trying to simplify this a little bit. Second of all, there are some smaller graphics and things, so if any of your beautiful faces want to move up closer, you're more than welcome to. I'm not going to bite. And then on top of that, we're going to come to some more complex business process slides. So rather than waiting to the end for questions, if you guys have some questions that we can help clarify while we're going through some of these slides, please feel free to throw your hand up. I'd rather address them then and there so you guys can actually understand the rest of the presentation rather than waiting till the end. Sound good? All right, let's get started with some intros.
Hi, I'm Marina Doltra. I am the manager over the distribution support organization within Oncor, and I am functioning as a functional lead on the project. And I've been with Oncor for about 8 years. I've worked on 2 major technology implementations, and this is the one that we're currently working on, and I'm excited to talk to y'all today.
All right, for those that I have not met, my name is Kyle Scanlon. I'm with Capco, and I'm a senior consultant there. I've been working in the utility and energy space doing project management and BA work for the past 8 years or so. I am currently the AUD project manager. With us today, we have our partners for this solution. So we've got the power engineers team. They are the leads for the GIS, the EAM, and the AUD work streams to do all the configuration work there. We've also got Capco here. We're doing some of the project management, BA, and QA related services for the implementation. And then lastly, we have SBS with us. They've been helping us with the architecture as well as some of the configuration components. We're all here, so if you guys have any questions, please feel free to reach out to us after the presentation. We're more than happy to walk you through any of the complexities with our implementation. So let's learn about Oncor.
All right, so who are we? We're a very small, no, I'm just kidding. So we are a regulated transmission and distribution utility. We're based in Texas. We are the largest in Texas, and we are the 5th largest in the US. We provide service to over 400 different communities across 98 different counties, and we cover roughly around 40% of the Texas map geographically. So you can see our service territory there. We're pretty involved in the community, and we empower the lives of tons and tons of Texans. We cover about 4 million different customers through their homes and businesses are help powered by our poles and wires. So our overhead network and our underground network all come in together at about 143,000 miles of service, and we have about 4,800 employees currently and growing. And so I'll let Kyle kind of cover a little bit of the growth of Texas.
Sure. So obviously, just like everyone else in this room, we are all dealing with our own challenges, and that's led us to one system or another. A lot of us chose AUD, that's why we're here, right? So one of the things that Texas is facing currently is an unprecedented amount of growth. We have plenty of people coming from other states moving in. There's thousands and thousands of jobs being created in Texas, so it's created a lot of demand. What does that mean for us? A lot of designs that need to be pumped out. So I know you all in this room are probably really fascinated with this beautiful PowerPoint. Maybe, it's really catch a tone with you. One thing to keep in mind here, if you're really looking to move to Texas, get a job at Oncor, whatever it may be, just remember it's about 100 degrees today, so Maybe Dallas isn't the right spot for you, so if you want to help us tone down the amount of people moving to Texas just for a little bit so we can get caught up, that'd be great. Next thing that we're working on is some added challenges from the customer side. I mean, the customer just has increased needs from their standpoint. Our developers want to get their work done now. You know, they don't want to wait till 5 days from now to get their design. So from that standpoint, we've had to find ways to work with them to make sure we can continue to keep up with the unprecedented growth in Texas. And not only that, make sure we're getting them the designs they need. We cannot have inaccurate designs that are causing them delays on their projects. The next thing we have is something we call SRP, not to be confused with the other SRP in the room, but that's our System Resiliency Project. This is essentially the Mother Nature issues that Texas has been dealing with lately. We have tornadoes, hurricanes, wildfires, a snowmageddon. All of this has contributed to the state of Texas reassessing how they're approaching utilities, and they're implementing some new standards that all the utilities have to follow in terms of hardening some of our assets. So that is a standards change that we've had to deal with that is going to cause, again, some more work and also changes that we have to deal with as a part of our AUD implementation. And lastly, it's an automation and data-driven world now, so how can we leverage automation to help our design throughput? That's another factor that we're looking at today, and that's why we've continued to explore more and more systems that allow us to do that, like AUD.
So let me give you a little bit of context in how we design today. So we have a GIS model today that does the material ordering, the geographical location, and the electrical connectivity model that then feeds downstream to our outage management system. It is really, really intelligent. It has a lot of moving parts and different components, but unfortunately, it's a bit like designing in PowerPoint. You know, you can do it if you really try, but it's not necessarily the right tool for the actual engineering design elements. And so we kind of recognized that when we switched into the current tool, because we saw that the way that we had our business processes constructed, the way that we've always been doing things, maybe isn't the best way to keep doing things as we move into a more integrated world, and as we tie in these additional complex tools that require so much more information than what we currently have on hand. And so our main drivers for kind of pursuing AUD is some of the stuff that Kyle already touched on. We need really accurate designs. We need them to be consistent across the board, right? We need everyone to be designing the same way. If we're designing in West Texas, it needs to look the same as if you're designing it in East Texas. And then also, we need to make sure that that connectivity element, the stuff that we're feeding to our outage management system, is pristine, which needs to make sure that our design piece is just fantastic. It knows, you know, that your pole is connected to this, that's then connected to that wire, that then runs upstream, that's fed by this feeder, and so on. And it needs to be easy to use. We have a very growing population. We're turning out a lot of designs, and so we need to be able to have those designs being put out at a very consistent and high quality manner. And overall, you know, we need to bring on new people to do all that designing, all those wonderful new hires to Texas. They need to be able to be up and running and be able to supply very good designs pretty much immediately when they get onboarded. So those are some of our concerns and kind of where we are today with our current system. And I'll let Kyle kind of touch on more of our business case.
Sure, so where are we at today? Well, we went through and assessed the industry landscape of what tools can we look at that actually will help us with our design throughput. And so we did an initial assessment and we found AUD, and from there we looked at the AUD's offerings, what they're able to do automation-wise, and how they're able to plug in with our architecture, and thought this is the best system for us to proceed forward with. So from there, what's our goal? How are we going to leverage this system? So our main focus there is we want to leverage the rule sets and the automation that AUD provides to maximize our value of getting better designs out at a quicker pace. So at a high level, our scope for this is configuring AUD to Oncor standards. We're going to integrate this solution with our EAM and GIS. We're also going to figure out how to actually push this product to all of our designers as well as our contractor designers. And then lastly, we're going to implement the business processes that our designers need to actually be able to go through the whole business process lifecycle and make sure they're well trained on it.
All right, So here are some of our by the numbers. So on an average, we churn out about 700 work orders a week. So that's how many we approve. That is not how many we have coming in, but that's our current throughput. Through some of our initial analysis of the AUD software, we took 2 designs and paralleled them between our current design system and AUD. Our current design system took about 34 minutes to complete the design. AUD took about 5. So that gives us a lot of hope. Obviously, it's greenfield design. There wasn't any of our complexity in there. We understand, but we're very hopeful that, throughout system-wide, once we bring in AUD, we're expecting to see about a 25 minimum increase in our throughput of design. So hopefully we'll be able to churn out as many as we have coming in. Our workforce is about 850 designers. About half of them, or just over half, are contract design resources. And of the 6 teams that we're going to be putting in, of our 9 total design teams that we have across the company, we're thinking we're going to impact about 90% of our designers with the tool. So it'll be a pretty substantial shift and a pretty big change for us here at Oncor. Like I said earlier, our designers need to kind of hit the ground running as soon as they get hired on. Today, it takes about a year with the things that they learn about the design system, the standards, project management, all of those elements. It takes them about a year to get them to get comfortable. I'd say about 4 or 5 of those months is getting them comfortable with the design tool alone. And so we expect, because AutoCAD is pretty prevalent in colleges, it's a really widespread and adopted software, we expect that time for them to kind of jump in and get ready and be able to use it to be shortened, because they'll already be familiar with the AutoCAD software. And overall, like I said, we do have the designer kind of managing the work order end to end. So they're the project manager, they are the designer, they are the connectivity expert. We're hoping that by kind of decoupling the connectivity element and having that GIS technician really own the placement of the GIS features and making sure the connectivity is good, we allow that designer to really kind of focus in on their design work, on their project management work, and kind of allow the true engineering design to be the designer's role, and allow the connectivity and the electrical component to be that GIS technician's role. That's it.
All right, so there's our timeline.
For now.
Let's talk to this a little bit. So the first thing we did is actually do a bit of a pilot phase with SBS team. We wanted to make sure that before we bought all the licenses that this solution was truly going to work for us. So we brought the team in, we gave a few basic requirements, we made sure that we could do some rough designs and do a playback into our GIS system. Once we figured that out, we proceeded to phase 2. So the first thing there, we started off with some scoping. We may have done some scoping a few other times, that's a minor detail, but we figured out what our MVP was going to be and then proceeded to go into some requirements gathering. From there, obviously we're working through our configuration right now. We're also working through our environment strategy to make sure we have a good release path ready for moving up into different environments, as well as deploying the solution to all of our designers. We've also done a good amount of testing, and we have started doing some of our training as well. We did our first round of training to teach all of our designers the basics of AutoCAD. We're going to be rolling out some AUD training here in the upcoming months. Lastly, one thing to look at is our stakeholder engagement. So we've done communications throughout this whole process to the designer team to make sure they're aware of the tool and they can understand how that tool is going to affect their future business process. On top of that, we've just continued to make sure we're doing a good job of upward reporting to our stakeholders to ensure that they have good awareness of what the project has been able to accomplish and where we're headed. Our go-live window is a little bit in flux there. We're continuing to have conversations on some of our scoping and requirements that should be in and out. Once we finalize that, we'll have a better idea of where that go-live window is going to be. But for now, we're looking at sometime mid-year in 2025. All right, Marina's going to go through the construction life cycle.
So it's now is phase 1 of boring you to death. No, I'm just kidding. So this is our overall construction life cycle today. Most of it's managed by Maximo, but just no different than maybe what you have in your different companies. So you have the initiate phase, you got a scoping phase, you got design, review of that design, approval, and then we have the scheduling of the work, construction, reconciliation, and work close. Easy enough. These are all the different applications that we leverage, and this is kind of how we see AUD plugging into those different systems. So Maximo is kind of our driver, it's our brain. Everything communicates to Maximo. We then have AUD and the GIS solution kind of touching in the design portion and as well as that reconciliation portion because we do have to reconcile our material in the GIS today, and we'll have to do the same in AUD. And you have, our construction scheduling tool, our, field app for them to be able to complete the construction work, and all of that is part of our overall work order lifecycle. So if that was super thrilling and exciting for you, I will now walk you through our existing business process and how we tango between all of these applications. So Maximo creates that work order. We then kick it over to our GIS system. There we can start a design. We will basically pick out all of the CUs and the materials in that AGIS tool, and we'll do our calculations. Some of our validations are in the AGIS tool. Some of them are standalone on spreadsheets and what have you, maybe a napkin on your desk. And then we will take that design that we've estimated and designed into the GIS and kick it back over to Maximo. At that point, we'll run a calculation on the estimate, so basically take that bill of materials, run a calculation of how much it's going to cost, and then we will approve the work order in Maximo. That approval is really what kicks off all of the other downstream systems on what happens next. It's basically us saying, this is what we're going to do, I've agreed that I'm going to do this, and now we pass it on. So at approval, we post their data into our GIS database, and then it gets migrated into our outage management system. All the features that we've placed basically get a proposed status that then can be visible in our outage management system and could potentially be manipulated as well, but you can see them in our live model. After that point in time, in a normal scenario, you have the construction get completed, and once construction is completed in that field mobile application, they will mark the facilities as in service, which means that they are energized, and then that command will go to Maximo. Maximo will then kick it back and basically say, push these features into energized status on our AGIS system, and then they will migrate to OMS as such. Then we get our as-builts. So if we get our as-builts after that point in time, we would then get those features and put them into the GIS, and then they would be shown as-built proposed features, and they would be next to our currently energized features, right, that went in service earlier. Any of those edits that we make in as-built get posted immediately as-built proposed. Once we get all of our materials kind of in a row and figured out and all the as-builts are completed, that's then when we say, okay, this is it, we're done making changes. We will tell Maximo to close the work order, and at that point, it will trigger one final time a closure batch that will then publish all of the features, the as-built and the existing energized features, all into a closed, energized state. So Kyle said this earlier, but this is a really high-level oversimplification of the back and forth between these systems. So I definitely skipped over a lot of the detail, but I think the key here is to kind of know that after that approval point in time, we allow the designers to make changes live all the way up until that closed job. So we post to our OMS at any point after approval. And so when we were talking about bringing AUD on, we needed to figure out how playback was going to integrate into that process to allow us to keep that live map as close to real time as possible. So it's kind of how we have it today. It's a little different than most, I think, and it adds an additional challenge, right? Because I can't just make my as-builts in Maximo. I can't just make my as-builts in the GIS. They have to happen at the same time from the GIS to those other systems. So, now that we're through that, here's how AUD is going to impact our existing process. So, started Maximo again, yay, no big change there. We're then having that go immediately to AUD. We'll do the import, we'll do our calculations and estimations within AUD, and submit that design estimate. Once it goes to Maximo, we say, all right, we approve, same process there. It will go through that approval batch through Playback, and then it will post that data after it's been approved in Maximo. So one thing I didn't really touch on in the last slide is that today you can have that batch process happening and the Maximo work order be somewhere else in that system. If that batch fails, there's some asynchronization that can occur. It gets a little messy, but through this implementation, we've decided, all right, we're gonna make sure that it actually goes through that approval batch first before it can ever be played back. Once that data is played back, then construction can be completed, we can migrate into the OMS, and then kind of follow the same process there. The second change that AUD will bring into the overall life cycle is, of course, in our as-builting. Once we are ready to as-built the data, we will complete our as-builts within AUD. We will still post those as-built install features and have them ready to be played back as they're being as-builted through the process, all the way up to work close. So we didn't really change that process. We just added AUD in there to be able to do the actual design engineering element and having that playback and posting of the data happening separately in that GIS system. Kyle, what'd I miss?
Yeah, one thing to touch on here, and this was a hotly debated topic, but we did decide to go for a GIS tech role. So before, in the previous workflow, you could see that the designer was working through the whole business process. Now we've introduced that GIS tech to actually perform that playback and GIS function.
So that did bring up a lot of concerns for our real-time model, as I mentioned earlier. We want things as close to real-time as possible, so part of the introduction of that role is including some SLAs so that they do get those playbacks completed very quickly so that our maps can stay as updated as possible. So now I'll kind of talk a little bit about our as-built process. So like I said, at any point after the work order is approved, we allow our designers to complete as-builts. So anything after approval is considered an as-built, even though most of the time a true as-built is really at the end. But basically, we have three kinds. First one is called a pre-construction as-built. It's I've done my work order, I gave it to the crew looks at the piece of paper and goes, I'm not building this. And basically, at that point in time, there is a discussion before they'll start construction. That designer will have to go back into the system, update the material, and hand off new prints. Then they'll go and do the work. Let's say they didn't catch it on the pre-construction meeting, they didn't catch it before they already started their building. Great. Well, in the middle of building, they go, oh, I think I want to make this change, but before I have this crew go out and work on it again, I need the prints to be updated, I need the material to be updated, we need more material. Those are called our real-time as-builts, and so we will go again into the GIS, update that material, update those prints, and hand that off for them to work on. Once construction is completed, and then the material is returned, everything's reconciled, if there was anything that we didn't need an update of material for, meaning we didn't need to see new prints, it was a small edit, small change, maybe a swap of a material, but there still was an as-built from an accounting perspective, we will then do as-builts before the design is ready to close. So in an ideal state, we'll get all the material reconciled of what actually was used. We'll get all the napkins, all the extra sticky notes, text messages from the crews that say, here's what we did that was different than your design. And then the designer will go in and implement, update that information, and then route that work order to close.
All right, I need a deep breath before we get into this one. So, obviously, there are a lot of things that we had to implement in order for this business process to work properly for what Oncor needs. One thing to keep in mind here is that not all of our groups are transitioning from our existing solution into AUD. So design work is still going to be happening in Aegis, which is our current design tool. We had to take that into account, and because of that, you can see quite a few changes here. I did not want to make a graphic for every single one of these changes, so I'm going to do my best to conceptually talk through a few of these to give you guys awareness. So the first thing is we implemented a unique identifier between our two systems. So if I'm doing design work in AUD, I'm going to have a unique identifier that gets applied to every feature. Same thing in our existing tool. And what that allows us to do is it allows us to complete our as-built process. I am able to, in AUD, know the unique ID that I put through for a feature, and if anything happens to it during that process, maybe someone else touches it and changes that feature somehow, some way while you're in the GIS system. Once I pull my information back into AUD and start doing my as-built, well, that universal ID is going to allow me to know if anything has changed about that particular feature that was originally in my design. The next item here is the modifying of the export to handle reversals of status changes. So this might be something where I decide I have an existing asset, I'm going to remove it in my initial AUD design. But then once I decide to do my as-built, I might say, you know what, I didn't actually want to remove that asset, I want that to still be existing. So we had to figure out a way to actually deal with that because we can't blow away that information if it was marked for removal, because we need to make sure it ends up being able to be pulled back in as existing if we want to do some sort of status reversal. The third thing here is the ability to recall design. People mess up. Sometimes we might just want to simplify this process. If a designer realizes they sent something to playback and they now know that they want to do a different change, we wanted a way to pull that out of the queue so that it doesn't get played back and then subsequently go all the way downstream to our OMS. So we have a request here to make sure we can pull back a design that gets sent to playback to avoid those scenarios. And then lastly here, we've got the connectivity solution. So Kyle Baker can explain this a lot better than I can. Essentially, we're using ports to pass along some of that electric connectivity. Don't look away, Kyle. You know this. The important thing here is somebody named Kyle knows what they're doing here, and they know how to implement this. So hopefully we get that one done as Oncor needs it. The last two things here, they're not directly related to as-builts, but they are other unique features that we did want to implement as part of our solution. So the first one was additional ID statuses to account for data corrections. This scenario would be if I pull in information from my GIS system into AUD, and I look at that information and realize this isn't actually what's in the field. So I might go in and do some tweaks to that data that I brought in as existing and say, here's the actual representation in the field, but I'm going to mark it as a data correction so that while it gets posted to the GIS as part of this work order, all the financials aren't directly accounted towards that work order. And then the last thing here is a conflict detection tool. So this is simply, we have people working in Aegis, we have people working in AUD. So if they do an update onto a feature that I'm working on from AUD and Aegis, I need to know about it. So we've designed a tool that allows us to know, hey, I'm about to export my information. Oh wait, somebody else already touched this information. Let me go see what they did, do some more updates to make sure I don't try to put in a conflicting change once we do our playback. Hopefully I didn't lose you all there, but those are some unique scenarios. Yes, we got a question?
In AUD, or is it going to be in Aegis?
It is in AUD. Cool. All right, I'm going to move on to how we implemented some things to leverage AUD. So for solution deployment, obviously we rolled out AutoCAD and automated utility design. I wish it was that easy just ending there, but there were a lot more things that we had to do on top of that. So I'm sure you all have battled some of these same challenges, but I'm going to walk through a few of these just so you guys are aware of some of the more complicated things that we had to tackle. So the first one is Oracle client updates. AutoCAD uses the 64-bit version of the Oracle client to establish its database connection. Guess which version Aegis uses? 32. So we've got two systems that we use. We might need them to be on the same machine. We had to figure out how to get two different versions of the Oracle client working on the same machine. I know Len Jewell is not here, but that man deserves a trophy for figuring this one out. So we did figure out a way to make these work at the same time, but it was definitely a challenge there. The next thing are some database modifications. So we had to create two new schemas in our GIS database, one to house the UDH GIS information, one to house the UDH EAM. On top of that, we had some DLLs that we had to modify and throw in there as well. One important thing to note here is that we have a Kerberos authentication solution that allows our designers to actually seamlessly log in and connect to the database when they're in our Aegis solution or the AUD solution. That is one thing that we had to figure out how it was going to work with the AUD solution, but essentially this masks their credentials, so designers don't know their credentials when they're logging in so that they can't just go into a SQL developer, log in with their credentials, and start querying databases or trying to do update, insert statements, whatever it may be. Last thing here is virtual machine profiles. Sergey helped us out quite a bit here on this one, but when you do an initial install of AutoCAD and AUD, it's installing it on the admin users. So when you have a virtual machine, we have to have a way to disseminate that install properly to the profiles so that all of the application components actually work properly when someone logs into the virtual machine. So that's the solution deployment. Let's jump into the hardware. We had to stand up some additional integration servers to actually allow us to do all the communications from external sources into AUD. So purchasing hardware was not on our bingo list for servers, but it became on the list. Next thing is laptop changeouts. Obviously, AutoCAD is a little bit more of a heavy product, so for some of our designers, we had to upgrade their machines. In addition to that, our designers house a lot of information on their machines, so we had to do some hard drive upgrades as well. And then virtual machine capacity, I was actually having a conversation earlier today about this, but as I mentioned, AutoCAD is a pretty heavy product, so we had to purchase some additional capacity on our VDI solution so that everyone can jump in there and actually use the product in an efficient manner. All right, and then the fun one, business process. So we did include the GIS tech role. We covered that previously, but that's another thing that we are going to have to solution, figure out what the actual GIS role entails in terms of what's their database access, what does our job description look like so we can actually hire people for that, so on and so forth. Yeah, that's your job. So the next item here is a drawing repository. So right now we mainly just post our drawings to SharePoint. So we're actually using the UDH enhanced solution, essentially a NAS drive that's going to house all of our information so we can check in and check out our designs. So it seems to be a fairly straightforward solution there, but it's a different way of working than we were using before. We've also had to do enhancements to our existing GIS system. It manages some of the job data, so on and so forth, so we've had to update some of the database components there, as well as just the ways that the system actually works in order for it to work with the AUD solution. Next item here, and I know this has been kind of a hot topic, but we've looked through our way of supporting all of our designers. So we're going to have a help desk set up to actually field questions, calls, whatever it may be once we go live. So that's one of the things that we're developing a RACI for, to understand if we have certain questions, who does that go to? And then lastly, engineering standards release. I think I've talked to about 5 people about this one since I've been here, but obviously it's a little bit more of a path to get engineering standards put into an AUD solution per our solution today. Right now, they can pretty much just do CU changes in Maximo and release them. Today, that's a little bit quicker than the AUD solution will be, where we've got to go in and actually assess what those standards changes might do to our models and update those and release those. So we will go on to the next solution here.
We had a question, Kyle.
Oh, sorry. Go ahead.
I was going to let you keep going, but so a couple of things. Well, yeah, I know. It's okay. On the as-built, a couple of questions there, if you don't mind. Are you working on a different versions each time you shoot to playback, or is that just going to sit in a version throughout the 3 different?
So we'll have a new version each time. Well,
It's one version? Okay. So every time they export out, it'll be just updating that one version? Okay.
if you're talking about the design file, yes, but we will append a version number for each submission to our asset management system. So it'll tell that there's a new payload that's coming.
Okay, on the asset management
Yes.
side, but the GIS side, it'd be one version.
Correct. We're going to jump into some of the hurdles we've been facing with our solution. So I'm going to start off with a few challenges here. The first one is the product architecture, limiting some of the AUD configuration to like a single-threaded approach here, or I guess limiting a multi-threaded approach. So what I mean by that is our stakeholders really wanted to leverage more resources in order to speed up our timeline. You hit a bit of a wall here with the AUD product in terms of at some point it doesn't really make sense to throw more people at the project because trying to merge the AUD template from 15 people doing changes all at once gets really confusing, and they might be doing changes on top of each other, so on and so forth. So at some point you kind of hit that limit on how many people can actually be doing that configuration, which means you can only have so much throughput on requirements per week. That's one thing that I don't think our management had a good understanding of initially, so we wanted people to be aware. We do think our team is doing a great job of doing as much throughput as they can, but obviously you can't just throw an endless amount of bodies at it and get it done. The next thing here is license management and user experience. So we have 850 licenses or so that's a lot to manage. We've got to assign all those licenses out, both AutoCAD and AUD, and we've had to come up with a solution there to actually make sure somebody can manage the turnover of employees going to different groups or contractors moving out to get that license back and reassign it to somebody else. On top of that, there's a user experience item here with the login. So the SBS team has a new solution for this, but previously you did have to put in your specific SBS password in order to access your license. Now we have a single sign-on solution that's going to help alleviate that, but it was just one more password people had to remember, which obviously didn't lead to as good of a user experience. Pass it over to you.
So as far as additional challenges from the user experience, of course, the playback and connectivity into the GIS, because our designers had that connectivity element, and obviously we have to do those multiple as-builts that I talked about earlier. That presents a very big challenge. And so it was kind of figuring out how playback was going to work, how to do it in a timely manner, how do we want to kind of govern that. And that's been a large discussion of our project is figuring out how to make sure that that GIS model doesn't suffer and that our OMS system gets latest and greatest data as we're moving along on the work order lifecycle. Additionally, Kyle mentioned earlier, had a little Dalaska event a few years ago, Dallas, Alaska, as I like to call it, and those events, those weather events, have cascading regulatory impacts that then impact our engineering standards. And as luck would have it, they're happening right in the middle of our project. So it's not really great to have all of your engineering standards change when you're trying to get them all down and written and get them into the new tool. So that's been a really big hurdle for us just from a volume perspective. We've had more standards changes in the last year than any other year before. And then, of course, as-built design, with our as-built design and the GIS complexities, those have all been discussions that we've had because we have to do the as-built in the GIS or in AUD and have that feed up to our EAM or to Maximo. That's kind of been a different experience than maybe a normal implementation would be for as-builts.
All right, let's finish off with some lessons learned here. So, don't fight me on this one, Pat, but what we've noticed here with our solution is that it's a little bit more of a waterfall approach. So SBS does do their due diligence here to work with us and make sure everything that we requested does find its way into our solution. So there is an agile nature here. I know they say they have a semi-agile approach. I get that they will make sure that we have what we want, and they're going to continue to adjust the requirements as necessary to make sure we implement the solution that we need. However, I would say when we're approaching an implementation as complex as we've designed, we've had to work through the business process quite a bit, make sure we understand all of our requirements before we really jump into doing a lot of that configuration work. And because of that, obviously we're not just going to see implementation that we can start using as a go-live implementation within a year. We're going to have a little bit more time to actually develop everything and get that out to our end users to use in a production capacity. The next thing here is properly scoping the POC and MVP implementation. So we did initial pilot of the solution, and While we did gain some knowledge there, I don't think we focused on some of the right things. So we spent a lot of time on that pilot, and we didn't recoup a lot of the investment that we used there because some of the things that we did there just kind of had to be scrapped because it was really for demonstration purposes instead of for long-term use. So making sure that we set clear guidelines for what that pilot needed to be would have helped us either, one, reuse some of that material a little bit more, or number two, maybe we could have sped up that timeline a little bit on the pilot to make sure we didn't spend as much time throughout that process. The next thing here, we bounced around a bit on what our MVP implementation was going to look like. I'm sure others have as well, but trying to define that as clearly as you can up front definitely help you to reduce your timeline as well. The last thing here, Oncor has a very secure cybersecurity approach. So one of the things we didn't realize was that there was going to be an admin rights requirement for us to do our AUD development. We also don't do admin rights through a VDI or virtual machine. So we had to send physical laptops to all our configuration team members because that's the only way we can give admin rights. So making sure you have clear upfront expectations from your implementation vendor and as well as setting those expectations with your IT department is definitely crucial to make sure you don't have delays there. On top of that, I would say another hindrance here is the AUD solution can only point to one environment at a time. You have to reinstall if you want to move to a different environment. Our designers cannot reinstall, so we had to come up with a remote deployment solution that kind of just allows them to switch their UDH configuration to allow them to point to a different environment, which is a little bit more tedious, but at least that's not providing our designers admin rights, which is what our cybersecurity team wants to avoid.
And lastly, from a functional perspective, so Oncor's been going through a lot of technology changes over the last couple of years. My organization's main purpose has been to facilitate the discussions and kind of represent the functional side of our business needs in technology projects. And so when this project kind of came about, we felt that it was really important that we had representation from all of the different design teams fully engaged, not just partially engaged in, testing here and there, but they've been involved 24/7, 24/5 on the project so that they could basically provide their feedback in a timely manner, help build requirements, kind of have their say of how they wanted this tool to be built. And so we think it's really important to have that be a dedicated source, a dedicated SME, and then we'll leverage those users once we get ready to go live as local SMEs and their individual groups. And so that's something that we've really been focusing on and making sure that we have that attention to detail at all scales. And then, of course, the aligning of said standards across groups. We have 9 overall design teams, and we had 6 specifically that were going to be part of our initial release. We needed to make sure that their interpretation of the design standard philosophy was the same across the board, and how kind of some of the automation elements in AUD were to be standardized across those teams on how we design and how we apply those different standards within a given design. So that was a lot of discussions had, a lot of workshops, and really helping figure out how we wanted this tool to work for our designers. And so with that, we'll swap over to Q&A.
Just first, great presentation, full of detail. I have so many questions. I'll catch up with you after. But one I wanted to ask, clearly you've put a lot of thought into this. It looks like it's really well planned out. What are the plans for post-go live in terms of support, maintenance? You referenced engineering standards, which really resonates with me, and I've heard it from a lot of different people over the last couple of days. What are your plans for keeping your template updated as these engineering standards change, as your materials change, things like that? I'm just curious.
It's a really good question, and part of some of our ongoing internal discussions between us and our standards department. We do have, in our support function, the configuration team there, we have a user prioritization team that can kind of help prioritize the changes that we'll have coming in, and we'll be partnered with our technology partners on the independent releases of changes to AUD. Now, as far as how are the engineering standards going to be changed and how are we going to update the models as they come along, Our desire is to build a model, we have a ticketing system where they would basically, go through all the back-end engineering stuff for figuring out what is gonna change. And once they know, they would then hand that off to my support team, which would then do the configuration and model update, and then they would publish the standard. That's what we're hoping to get to, but there is a potential reality that that might not be the case, and that our models may be behind the currently published engineering standard, but it really is going to be, everything that we do as far as when updates happen, how we update the template and the models, that'll all be through a ticketing system, and the timing of when things are going to be released is kind of where we're trying to figure out. Ideally, though, standards would hand us the package, we would build it, and then we would publish it. So.